After I published the initial desktop embedding video, I kicked myself because there was this one very obvious thing that I should have done that I didn't do. So let's rectify the situation. The program I'm using here as a backdrop is an old chestnut that I developed for Lawrence Berkeley Labs back in 2002. It's an interactive protein manipulation program. The idea is that you have a protein structure like this one, which I made up completely, and then you fold it manually into its final 3D shape, like this barrel of beta strands here, and then surrounded by these alpha helices. Again, this protein, I completely made that up and assembled it by hand. The way it works is that we are currently looking at a cartoon rendering, so you can select a secondary structure like this alpha helix, which will put a box around it. It will highlight this coil region, connecting it to the rest in yellow. Then we can do the same thing down here, select this coil region as well, and then you can just pick up this structure and drag it around, and you see how the coil regions will follow to mean that the chemical composition of this, at least locally, is always valid. Instead of showing the cartoons, we can also show van der Waals spheres. Well, that didn't work. We can also show van der Waals spheres like these ones, and so then you see, if I drag this around, you'd notice how the amino acid residues along these coil regions change the conformation. They rotate around their dihedral angles, about their degrees of freedom, in order to accommodate the motion I'm doing here. So what I'm doing is essentially inverse kinematics on a fairly long chain of rotational joints, but that's sort of beside the point. What I want to show is that, again, remote embedding. Let me put this over here, and let's bring up, actually let me use the mouse for that, let's bring up the VNC client that shows us the remote desktop. Now in this case I'm not running the remote desktop from a local machine like in the last video, but I'm remoting into my laptop here, which is why this is now going to be a lot choppier and higher latency than what we had before, because now I'm going over 100 megabit per second Ethernet instead of just copying from the local machine. But that's sort of also the point, to show what that would look like. You can see that there's now a lot more latency and a lot more choppiness there. So the thing that I didn't show last time was, I mentioned that I can run any application in the VNC session, but the fun and obvious thing to show would have been, of course, to run the exact same application that I'm already running in the 3D environment. In this case, I'm going to now run ProtoShop as well, and here we go. So that is now the same application run in 2D mode, so to speak. So let me zoom in here a little bit, make that a bit easier to work with. There we go. So what that means is, actually let me pick this up and move it over to the side, get it out of the way. Okay, let's put this here so I can always look at it. Let's put this guy, whoops, wrong button, let's put this guy back here. So now here on this side I'm running the application in desktop mode, so here I can use the mouse to, okay, maybe that wasn't so clever. Here I can use the mouse to interact. So what it means is I can, use the usual 2D trackball to move the model around. This dialog I want to close, I don't need that. Come on, here we go. So I can use the usual virtual trackball to move things around. I can do the same interaction on this side, so I can, let's see, I can select a secondary structure. I can highlight the coil region down here, and then I can drag this around like so. And what I didn't mention a moment ago is that now the program is actually running collaborative mode. So I'm running two instances of the protein folding program on two different computers, controlling them both through the same computer. This one here primarily using the 3D input device, and the one on the other side primarily using the mouse. But the two of them are hooked into each other, which means that any changes I make on one end are going to be replicated in real time on the other end, just to make the linkage complete. So we have like a double linkage. These two are connected via VNC, but then also through the actual protein sharing protocol that makes it line up. So that was really all that I wanted to show here. Just the fun idea of sort of being inside the program, or running the program in desktop mode while you're actually having your 3D device on and running it in 3D mode as well. Let me see. There's really not much more to talk about here. So that was that. Just a fun little excursion into stacked reality, so to speak. Okay, that was it. Have a good one.